Today I'm going to talk about the second fundamental theorem of calculus, and I will also remind you about the first fundamental theorem of calculus. Let's remember what we said about integration at the beginning. We said that integration of f of x dx is represented by capital F of x, and we said that if you derive the answer of integration, that should give you what's inside the integration, which is small f of x. So for example, if I said that f of x is equal to integration of x to the power of 7 dx, and I ask you to find f prime of x, then immediately you will say that f prime of x will give me what's inside x to the power of 7 without even working that out. Well, that's good. What if the question was this case? Capital F of x is equal to integration from 1 to 2 of x to the power of 7 dx. If it was definite integral and I'm asking you to find the derivative. Well, let me remind you of the first fundamental theorem of calculus. What does the first fundamental theorem of calculus says? What does it say? It says that capital F of x, if it's equal to integration from a to b of f of x dx, then that will be equal to f of b minus f of a, and that's what we use to do to evaluate definite integral. So if I have definite integral, then the answer will be f of b minus f of a, which is usually, since these are numbers, this will be a constant, a number also. Since it's a constant, then such an integration will give me a constant. So in this case, f prime of x will be equal to 0 immediately. No need to think about it. Great. Now, my question is, if capital F of x is equal to integration from 1 to x, not to another constant, of t to the power of 7 dt, what will you do here? Let's go through the process and see what can you conclude of that. Let's try to integrate this. This means t to the power of 8 over 8 from 1 to x. If you try to evaluate it, this will be x to the power of 8 over 8 minus 1 over 8. So this is capital F of x, and I'm asking you to derive it. So if you want to derive, this will give you 8x to the power of 7, so x to the power of 7 immediately over 8. Let me write this in details. Over 8 minus 0, which is x to the power of 7. Well, how is that related to our original question? It's the same. It's just substituting x instead of t. So if I have integration from a to x of f of t, function that depends on t dt, then the derivative will be just replacing x inside. And actually this is the second fundamental theorem of calculus. Second fundamental theorem of calculus. It says if f of x is equal to integration from a to x of f of t dt, then immediately f prime of x, the derivative of this integration, will be equal to f of x immediately. So you just substitute x inside. That's actually the second fundamental theorem of calculus. But I want to go further than this. Let's say that I have this integration. Capital F of x is equal to integration from 1 to 2x cubed plus 1 of t to the power of 7 dt. What if it's not x, if it was a function like this? What will you get? Let's work it out, because I'm sure that you are expecting an answer like 2x cubed plus 1 all to the power of 7, according to what we did, f prime of x. That's what you are expecting, right? So is that a correct answer? Let's check. Is it correct? So let's go through the integration and do it. We already did the integration. It's t to the power of, here, it's t to the power of 8 over 8. So I'm gonna jump to that step. So this means we have t to the power of 8 over 8 from 1 to 2x cubed plus 1. Substitute. This will give you 2x cubed plus 1 all to the power of 8 over 8 minus 1 over 8. That's your capital F of x. Now, let's derive it. If you try to derive here, if you try to derive this expression, this is a composite function. So what's the derivative of a composite? That's a general power rule. So actually it will be derivative outside, keeping what's inside, times derivative of what's inside, all over the constant, minus 0. When you simplify, 8 with 8 will cancel. So you will be left with 2x cubed plus 1 to the power of 7 times 6x squared. Now, what's the relation between this and your original function? The original function was t to the power of 7. Did we substitute? Yes, we did. So it's the same as the fundamental theorem of calculus, but there is an extra thing here. What was that? That was actually the derivative of the function here. So we can generalize the second fundamental theorem of calculus. General. Instead of saying that if f of x is equal to integration from a to x, I can say integration from a to a function g of x of f of t dt. If that's the case, then f prime of x will be equal to f of g of x, but multiplied by g prime of x. Well, is that the only general case? Let me generalize it more. What if capital F of x was equal to integration from g of x to h of x, from a function to another function of f of t dt? What do you think? What would that be equal to? Let me take you back to the first fundamental theory of calculus. What did we do? We substituted b and then substituted a. So what do you expect if you combine the first fundamental theory of calculus with the first and second, with this general form? What do we expect? Actually, what makes sense here is capital F prime of x would be equal to substitution of the upper function times its derivative minus the substitution of the bottom function times its derivative. So, for example, if I said find the derivative of integration of 2x to x cubed of t to the power of 5 dt. Do you need to integrate this to find the answer? From now on, no, you don't need to integrate it. If this is the case that you have, you can just substitute x to the power of 3 times its derivative, 2x times its derivative. So this will be x cubed to the power of 5 times the derivative of x cubed minus 2x to to the power of 5 times the derivative of 2x, which is 2, and of course you can simplify this to get your final answer. In general, these are the fundamental theorem of calculus, and I've generalized it for you. So I hope that this was clear. 15, 17 minus 32, 64 x to the power of 5. I hope that this was clear. Let me show you an example on this where we have trigonometry included. For example, if I said show that d over dx of integration of from sine x to cosine x of square root 1 minus t squared dt. Find such a derivative. Well, it looks complicated, but I want you to show that this will be equal to -1. Show that. Okay? Try to apply the theorem and tell me if you have problem. This is your question.